You've provisioned your infrastructure with Terraform. Now it's time to configure it automatically with Ansible. In this episode of DevOps in Practice, we're going to show you how to use Ansible to manage and configure the servers we just launched on AWS, building a dynamic inventory, testing SSH connections, and installing Apache based on the system's OS. This is real DevOps. Code creates the infra, code configures the servers, and guiding you through it all is our expert from the Cloud Bootcamp, Herbert Pereira.
Great, we're back. Now for the configuration part using Ansible. We prepared the environment where we created our workstation with the appropriate permissions to be able to create resources within AWS. Using Terraform, we provisioned the two machines, the two VMs with different operating systems, which will make up our host file that will be managed by Ansible. To do this, we need to create a host file. Let's open the host file and carefully prepare all the necessary information, remembering that Ansible communicates securely through an SSH connection. So what do we need to make an SSH connection? We need to know the IP address of the machine, we need to know the user of the connection, and we need to have the private key file. So it's precisely this information that you need to configure in the host file. And here you make use of the so-called Ansible facts, which are automatic variables collected by Ansible on each host. For each host, you'll notice that Ansible already maintains its own variables, where it includes the essential information it needs to efficiently and securely manage these hosts. So what exactly do I have here? I have two machines configured, host 01 running the Debian operating system with its own private IP address and its own dedicated user connection already defined. We also have another machine running the Red Hat operating system with its own private IP address and its own properly configured user for connections available. Depending on the environment, you'll have different operating systems. So this is one of the ways Ansible can work with an environment that includes different Linux distributions. To do this, I'm going to create a group of keys that applies to any machine, since they all use the same connection file key, right? Now we need to test Ansible's connection to these machines. Remember that Ansible is installed on this EC2 workstation environment. To perform this connection test, Ansible provides a simple built-in ping module. Here, I'm using the Ansible binary directly to execute the command. This Ansible ad hoc command runs Ansible by invoking its binary and specifying the inventory file, which includes the list of target hosts to be managed. Remember that it's possible to configure the inventory file dynamically. You can tell it which machine in the inventory you want to run this command on. In this case, I'm entering all because I want to run it on all of them. And here you can enter which module you want to use. In this case, I'm going to use the ping module to test the connection. So on both the Debian machine and the Red Hat machine, we were successful. Thanks to the steps we took earlier, all the communication setup was completed successfully, allowing us to reach this point and get this successful response. Our next step is to create the playbook file to install Apache on both virtual machines, Debian and Red Hat. So let's create the playbook file right now, which will be called install Apache. And let's configure this playbook file step by step. Here's the code for our playbook, which will be called installing Apache. It will be for all hosts, and it will have this become yes, precisely so that it runs in privileged mode in root mode. And in this playbook, we have two tasks. One task installs Apache on Debian, and we have another task that installs Apache on Red Hat. And let's get to the peculiarities, starting with the package manager. When we talk about Debian, we're talking about apt. When we talk about Red Hat, we're talking about yum. This way you can create a playbook in an organized and standardized way and have Ansible manage your machines defined in the host file. And here we're going to do the process of updating the cache. Here the name of the Apache package for Debian is Apache 2, while for Red Hat it is HTTPD. From the state section we have present value, which means that we want it to be installed. And this is where the trick comes in. When Ansible distribution checks the Ansible fact of this machine and identifies that the distribution is Debian, it will proceed with this task. Otherwise, if it's not Debian, the task will be skipped. Similarly, when the distribution is Red Hat, it will continue with that task. If it's different, it will skip it. It's as simple as that. Once we have created the playbook files, let's move on to the playbook execution step. But before we start this step, I'm going to show you the Ansible fact variables from both hosts. If you run an Ansible ad hoc command and specify a particular host, for example, our Debian virtual machine, using the setup module and passing the argument to filter the Ansible distribution, you'll see that within the Ansible facts of that host as01 machine, it shows the Debian distribution. So that's how the magic happens. In the same way, you can run this command for machine 02, which uses Red Hat, and you'll see that the Linux distribution lists Red Hat. Got it? Did you catch the jump? Got the hang of it? Great. Now let's move on to the execution step of our playbook. This time I'm going to use the Ansible Playbook binary, pass on our host file, which will be for all the machines, and enter the playbook file we've just created. And it will start the process of executing our playbook. When we enter the name of our playbook, it automatically executes the gathering facts task by default. This step is specifically designed to collect the machine's properties, populate the variables, and enable Ansible to properly manage all the hosts within the environment. All right? I'll be back as soon as I've finished. There you have it. The process is complete. Our playbook has been successfully executed. As I told you, in the Debian task, it skipped Red Hat, and in the Red Hat task, it skipped Debian. And here we have the end result, that everything was done successfully. Now, to be absolutely sure, we can run additional Ansible commands. For example, a command using the shell module to check the current status of the Apache service inside the Debian machine. And as you can clearly see here, the Apache service is active, running smoothly, and responding as expected. Now let's repeat the same procedure to verify how the Apache service is running on the Red Hat machine. And we'll see that it's not good. Note that it is inactive, not running. And here I have a challenge for you. How do I start and check the Apache service on the virtual machine Red Hat Linux distribution? And here's a hint. The service module is preferable to the shell module. But why? Because it guarantees idempotency. Do you know what idempotency is? Tell me in the comments. And now, let's test it to confirm that our Apache server on the Debian machine is truly running and responding correctly. Let's take the Debian EC2 IP address and run a test from the browser. It needs to be HTTP here, right? We don't have an SSL protocol set up yet. And there you have it. Our Apache is up and running. And to finish off this video, let's set up an HTML page and see what happens using another module from Ansible itself. Let's go back to VS Code and let's create an HTML page. Let's open it, insert a simple HTML code, and run a quick test. Back in our workstation terminal, let's now use the copy module. And what exactly does it do? It will act inside the host 01 Debian machine where Apache is running using the copy module and passing an argument. It will take the file we've just created and save it in Apache's default folder with the same argument B. This is the become flag run as root. Once we've done that, we'll wait for the result. So we've had a successful result. If we come back here to our machine, now inside our browser, and run a refresh, there it is. Our page has been successfully set up. So this is how you can effectively manage inventories across different environments containing multiple machines by using a host file in Ansible. And this was another DevOps in practice video, provisioning with Terraform and configuring with Ansible. And now let's get to the destruction of resources. To do this, you always have to be inside the folder where we created the resources. Let's run the command Terraform destroy, and it will destroy all the machines that have been created. Wonderful. Command completed successfully. Now we can close this remote connection, since we're also going to delete this EC2 workstation. I'm going to close VS Code. Back in the AWS console, we can now select the EC2 TCB workstation instance and begin the termination process safely. It was only for a laboratory, and if we update the status now, we'll see that these other two machines no longer exist either. I'm only filtering by the instances that are in the process of running. You can see that they are no longer here because they are already in the process of being deleted. We can also access the AWS IAM console and delete the role we created. Then comes another challenge. How can we delete this role using the AWS CLI? I hope you managed to do it. Leave a comment here and share it with others so they can learn how to complete this process too. Once you've done that, simply select it, delete it, and all the resources we created will have been successfully removed. If we refresh here now, this page no longer exists. Thanks for joining us, and I'll see you in the next videos.
All right, thank you so much for watching this video. And then if you enjoyed this content, please consider subscribing to our channel Give us a thumbs up if you enjoyed this content, and then also please leave us a comment telling us what you think about this video and also the things that you'd like to see in a new video here on our channel, okay? And then if you're interested in mastering multi-cloud DevOps and AI with our help, please check the links in the description as well. Hope to see you in the next video. Take care and goodbye for now.